¿Me escuchan? Good afternoon. Buenas tardes. Sí, okay. So sorry, I don't know usually why things go wrong, but it works now. I never have time to verify why it didn't work, but things seem to be working. So are there any questions for me? I posted a number of documents and I thought we could start here today. So what we've done so far, we completed Unit 1 as an introduction to time value of money, and now we are getting into much more practical applications after I introduced interest rate conversions. So we want to use interest rate conversions as a tool now to solve problems that are realistic. And I present coupon bonds, mortgages, valuing stocks, and just regular loans and investment opportunities, all as a training ground for valuing assets, right? So that's what we're going to spend some more time doing. Can you tell me how far you got in your review of the documents? Let's see if I can share the website. I think I have to log in again. I think I should be able to log in without Wi-Fi. So mention in the chat how far you've come with your review of documents. Oh, you don't see my pantalla. What is happening now? A minute. Oh yeah, you see that. So what are you telling me? In the pantalla, I want to start focusing, getting through these documents. There are quite a few. And then I end with the test prep questions, which are sample questions with answers only. I don't have the full solution, so you can also focus on solving those, verifying if you can get the right answer, and then next class will be 1 week before the test, right? So next class we can focus on the prep questions. So prepare the prep questions as best you can. Sorry, there it is. For next week. So where I'm starting is interest rate conversions applications. But are there any other documents that you'd like me to solve problems on or answer questions about? Okay, so I have a feeling you guys could benefit from any review, right? Is that correct? So again, I appreciate you attending so I can make this video for the other students and that they take the opportunity to watch in good time before the test. This is a hybrid course and the test will be in class, in the classroom. So it'll be on the 14th in the classroom, and you can bring with you a formula sheet that you prepare in your own handwriting with the relevant formulas on it. There shouldn't be anything else on those documents. I recommend one sheet of paper, front and back, regular 8.5 by 11. All right, it shouldn't be photocopied, it should be in your handwriting. After the test, I will take the formula sheet in with your test paper. The test will be multiple choice, but you can submit your written work to me as evidence of your interpretation of the problem and for any disputes. But I will just be grading the multiple choice responses. All right. No comments or questions, so shall we just get to the problems? All right, so in the next 2 weeks, we're going to be done evaluation and we're going to get into the next unit, unit 3. Here's an example in valuing a bond. Corporate bond paying semi-annual coupons, and that's usually how they are paid. Semi-annual coupons at an annual rate of 6% with a face value of 1,000, maturing in 8 years. Yes, the quiz, the solution, sorry, the problems in Connect. Oh, I lost connection again. The problems in Connect are going to be available to the week after, yes. All right, so that you can focus more on studying and then studying with the materials I give you, and then you can go to the Connect problems. Sorry, my connection is unstable. I don't see anything. Materials I give you, and then you can go to the Connect. Oh, the microphone doesn't sound great, does it? Let's work on the microphone sound. Let's see. How's that? Is that better? Let's make this a little bigger. Okay, so Oh no, losing connectivity. Let me look on here. It's black again. All right. Consider the corporate bond semi-annual coupons, 6% coupon rate, a face value of 1,000, maturing in 8 years. So we read this problem like all the other problems, and I actually prepared a summary document here called Problems Evaluation Summary, and those are the steps that I talk about. Step 1, identify the timing of payments, if there are payments, and convert all rates, interest, discount, growth, to an effective rate that compounds within the same frequency as the payment frequency. You should actually convert all variables to the same intervals. I didn't mention that here, but I should probably add that. So with that in mind, we know that the payments are semi-annual. So we need our problem, our variables in 6-month periods. C is the 6% rate that we're given. We take that C and divide by 2 and times by face value to get the $30 payment. So just like the rate is a stated rate, so is the coupon rate. Okay, so this is something that's maybe you never knew. And then with the face value of 1,000 and now 16 semi-annual periods, we can do the same thing for the interest rate where we see it as a stated rate. We have to take the interest rate and divide it by 2 because it's just simple interest and I want the effective interest rate. This is the rate here. This is the formula. And keep in mind, if you write this formula out on your test paper, this is not worth any points. It's the formula with the variable values included that earns you credit. Okay. So here I put in the annuity portion $30, 3.5% is the interest, 16 periods, and then here is the lump sum $1,000 that we get at the end as bondholders. So that's 16 periods later. Now with this, you don't have to use any mathematical or analytical computation. You're going to use the finance keys on the TVM row of your financial calculator. So for this problem, I get 16 in N. 3.5 goes into interest. Into PV is what I want to find, right? So PV is unknown. The payment we figured out is $30, and that's to be received, so it's a positive. And the face value is 1,000. So remember, we use all of the keys on the time value of money row for a coupon bond. And then we ask to compute PV. Remember, if you see the screen is blurry, reload, okay, to see it clearly. And also I noticed that I can see the screen perfectly on my iPhone that's relatively new and not on my monitor that's pretty old. So keep that in mind as well. All right, so do you all get this value? Let's do the next one. So I'll let you try that. Try and read through it, solve it. Try not to look at the clave right now, and then we'll do it together. Okay, so try this problem. So at this point, you're seeing that this bond is selling in the market, secondary markets, for $1,057.98. You know the terms of the bond. You know that it has a coupon rate of 12%. You know their coupons are paid semi-annual. The face value is 1,000 and it's maturing in 25 years or 50 periods. So what would be the yield on this bond? So you use the yield then to compare across the same asset class or the same bonds. You see which bond has a better return, right? A return or a yield that is that you require. So the idea being, the higher the return, and we're going to talk about this by unit 5, higher return brings along with it higher risk, more volatile returns. When it comes to a bond, we discuss the possibility, if this is a government bond, the government backs the payment to bondholders, the coupon payments, it backs it with the promise that they'll have to raise taxes to pay those bondholders. When it comes to buying corporate bonds will be paid, will have terms that require payment semi-annually, and then after the bond's matured, the face value of the bond will be paid to bondholders. And this is not 100% guaranteed, okay? So it depends on the productivity of the company, and companies can default. This isn't good. If they default, then bondholders have a legal claim on the commitment to pay those interest payments, right? So bonds returns or yield on corporate bonds are higher, but they're also more risky. Government bonds pay a lower return or lower yield, but they're more secure. So we'll talk more about that sort of thing, bonds and risk and investments and risks and returns, in unit 5. I thought If I didn't mention it already, I'll mention it here. So let's put this together. Now, yes, we could push this in our calculator. We know that N is, first of all, we identify timing of payments. They're semi-annual. So we need all variables should be converted to semi-annual periods for use in our formula. So N will be 50. Interest, we need to figure that out. That's what we're looking for. And then PV we have, and we'll make this a negative. The payment, we have to figure that out. So what's the payment? To get the payment is equal to C divided by 2 times 1,000, right? And you're told C is 12%. So there's two rates here, right? There's the coupon rate that helps you calculate the dollar coupon payment. And then the yield to maturity, or the interest rate. So this is 6. Or $60. So $60 is the payment and the face value. So these two things you receive, so they'll be positive. So I've done this, and this should get me no points on the test if I was grading your work, or if you're coming for credit. You need to write the formula out, but this will get you the answer. So if you compute I by Y, what do you get? It's just I don't want to lose the main point in this problem. What'd you get? Okay, you got me a number. Some debate, so I have to try it myself. All right, so you have to remember to make the price negative and the returns payment of coupons and the face value is positive, or this won't work. Okay, so I get the 5%. I get this, sorry, and I get 5.649995, and it repeats. I mean, it continues. Right, so I should store that. Store 1. Is this my final answer? Thank you, Carlos. Is this my final answer? Is that it? Is that it? Are you done? You finished? So I circle this? So go back. First of all, I have to write the formulas down, right? Formula has to be written, and we have to give the yield as a bond per year, as a rate per year compounded semi-annually. You have to give it as a stated rate. So first, let's write the formula, and you guys think about what I just said. But this is not the final answer. So we need, what we're getting is the effective period rate. That's what that is out of the calculator. But you need to state it as a yield to maturity as an R2. So this is like the simple interest, right? So I have to take 2 times the effective period rate to state it as over a year or annual period. And that will be your answer. Questions? So in that way, you're going to use the stored value times 2, and you'll get 11.29999.024%. Any objection? So what you can do to check it in the end is take that value and put it in to see if you get the right price. So if I take that value, divide it again by 2, put it in, no, it'll work. It'll work because I just got it out of, I just got it from my calculator, so of course it'll work, right? So then follow the instructions on how many decimals to report to finish the answer. It'll be a multiple choice test that I give you, so you just find the best answer. So that's your final answer. Questions? You got that? Am I going too slow? Let's do the next one. Oh, what happened? I just want to change pages, not get out. All right, so that's that page. And there's the answer, 2999. I put a 0, yeah. All right, let's do the next one. Just another coupon problem. And this time we're going to look for the years to maturity. All right, again, try not to look at the solutions. Try and solve this on your own. If you're comfortable now with the calculator, go ahead and try and put the data in the calculator, and then try and write up the formula. I'll give you 5 minutes. Do not look at the clave. Ready? What's the time? Let's see. All right, so if I put this in the calculator, it's a bond again, and the terms of the bond are usually the same. I mean, they're semi-annual coupons with a face value of 1,000, so that's pretty standard. So we have the periods we want to know. The interest we have, so it's 6.6 divided by 2. And then the present value is the price. And you pay that as a prospective bond holder. You'll pay that, and then you'll get payment, which is sorted out as 7% divided by 2 times 1,000. So I asked you to remember the formula. It was $35. And face value 1,000. So you can get the answer right away, and then you can take your time to write the formula out. So the only thing, don't get mixed up. Remember, coupons help you find the payment. It's also a stated rate, so you have to divide by 2. Yield to maturity is the interest rate, but it's a stated rate. You have to divide by 2. If it's not a stated rate, depends on what kind of effective rate it is. If it's an effective semi-annual rate, then that's good. You can use it. If it's an effective annual rate, you need to convert it to an effective semi-annual, right? We need to have EPR. In other words, we need our EPR 1/2. To solve this. Okay, so you're agreeing it's 17.99? Do you want me to punch it in? Or just verify? I get 17,998. Okay, so that's the answer for the periods, right? This is the number of periods. And they want the answer. You have to go back and look at what they were requesting as the answer. You want it in years. So this is in semi-annual periods. So periods or more, you have to divide by 2. So years is equal to that divided by 2. And you can put 8.99903, but you have to round to whole years. Okay, let's do the formula. So practice making the formula. The formula will be an annuity for the coupons. And then the basic time value of money formula. And that's it. So you would put this on your test, and then the final answer, well, you could show these two steps, right? Where you get the semi-annual periods and the years. So I'm just circling what I need to see. Any questions? Any inconsistencies? Did I make any mistakes? Okay, so next we're going to talk about the applications of interest rate conversions to mortgages. Valuing the valuation model or the valuation approach can be used to determine payment on a mortgage. A mortgage is a loan for purchasing a property, a home, a building, and it could be for a mortgage could be for your business as well as a personal residential. So a mortgage is an example of what's called an amortized loan, where the principal is paid over time, not at the end of the loan period, so that that balance continues to earn interest, not earn, but charge interest to you over the life of that loan. Banks often quote mortgages as annual interest compounded monthly, and that's in the US. If you're purchasing outside of the US, make sure you read carefully the statement of the rate. Okay, in Canada, for instance, mortgage rates are quoted semi-annually, although payments are monthly. So you have to do a couple of interest rate conversions there. It's not so hard with the American, I mean, it's not so challenging with the American quoted rates, because all you have to do is take the rate and divide by 12. Just like we talked about with the credit card, you take the rate and divide by 365 to know what you're effectively paying. So what we're going to do is go through the amortization process. Has anybody here done something like this before? So we're going to figure out what the payment should be for a mortgage. In this example, that's a 25-year mortgage of $100,000 at 7.4% per year compounded monthly. So no one's done this kind of a problem before. So you can get calculators online that will help you determine what a mortgage payment will be. But we're going to unravel what's behind the black box of the financial calculators online. So usually they just have boxes and you enter, the mortgage amount and the rates, and just tell you the payment that you can expect to pay. Now, when it comes to buying property, it's not just about the monthly payment. There are also other charges, other fees that are paid. And we're not going to talk about those, but just to warn you, it's not just about the monthly payment. There's other fees. And then if you have a realtor, then you're going to pay your realtor who helped you find the property and set up the mortgage. right? So origination fees and, I can't remember some other, at this moment. Anyway, they're fees and they could be substantial. So let's look at what we do with this situation. So we have a 7.4 per year compounded monthly mortgage. So we got to take that rate and divide it by 12. So this is what we pay every month in interest. So you can take that value and store it in your calculator. Store 1. So we're going to use it later. The first question is, what's the monthly payment on the mortgage? So this is an annuity where you have the present value. It's the amount of the mortgage, the amount borrowed. And the payment is what you want to figure out. So it looks like this. Here's your annuity. This is what you want to figure out, the C1, right? What you pay next period, it's going to be the same amount. So this is important for people who are budgeting. You know, you want to know what it's just like your phone payment, right? It's nice that it's predictable, so you can plan around it and you can raise enough money to pay your bills, right? In your case, right, you're going to be earning money or anyway, arranging to make these payments of the same amount for the next 25 years every month. So so I put the numbers in here, but I don't expect you to put that because that's a repeating decimal. I don't want you actually to do that. I prefer you to see if I can erase. I can't erase. I prefer you just to write out EPR 112. And here it would be 1 plus EPR 112. Meanwhile, the value is stored in your calculator, because some students, they put the numbers in here and you can just imagine how many mistakes you can make, right? Trying to enter a long decimal value like that. That's why we use the stored keys. So we need to convert all our variables to monthly variables. So we do our 25 years times 12 months per year into 300 months of payments. So that's that there. We already converted our rate. And so you put it into the calculator. Remember to multiply your rate by 100 because it has to be in percentage. And you should get this value. So let me give you a moment to see if you can get that value. Okay, 732.49. Yep, it's good. All right, so once you get the answer, we're going to do some other things with this scenario. However, we do not use all the decimal places, right? There's many decimal places, but in fact, when you pay your mortgage, you pay in dollars and cents. So it'll just be $732.50 for our future reference. Okay, so if we refer to the payment, we don't need all the decimal places. I'll wait a minute for the rest. Sandra got it. Okay, so this is very easy. This Adamaris, this is you're going to be really happy. All you do is divide by 12. It's very simple, right? Because this is a stated rate. It means that all they did to compute it was take the effective rate, multiply by 12. So we have to do the reverse, divide by 12. So it's very easy. If you hear about a mortgage rate, just divide it by 12 to know what you actually pay every month. Appreciate the question. So there's no FB here. There's no, it's not, yeah, it's just an annuity. So a mortgage is an annuity. We don't have an extra term here. It's just this one here, right? This is the annuity. So to find the payment, right, that's not, we don't have to do that, no. So the terms here are different than the bond. So very good questions. Clarified, put it all together to synthesize. This is its own animal. It's just an annuity. Okay, make sure you get it. Let me know, and then we'll get on to the next part. There's two more parts to this mortgage problem. You're going to get a lot of practice if you work on the test prep this weekend. Like I said, work on the test prep this weekend and prepare, or this week, and prepare your questions for me next Tuesday. Ready? You got it? Questions? Hope you don't hear the big noise in the background. Let me know if you hear the noise. I have to set up the microphone differently. Got a lot of background noise. All right, you guys are quiet. Hopefully you guys are fine. We're going to move to the next part, which says, how much of the first 3 mortgage payments goes towards principal and interest? So we're going to begin to prepare the amortization table. So we're going to make the amortization table. That didn't work. Try it again. I don't want you to see the numbers, but just this one. So this is so you can put this on your formula sheet. These are the steps to, or the columns of an amortization table. And we want to know doesn't work. I want to bring the question so you can see it. All right, so how much of the first 3 mortgage payments goes towards principal and interest? Oh, it's erasing. Oops. So, month number 1, what's the principal outstanding at the beginning of the month? It's $100,000. And then at the end of the month, there has been an interest charged. The interest is in your storage, right? Remember, the interest was this number that we stored. So, like less than 1%. So 7.4 divided by 12 is the interest rate times 100. And so what you want to do here is figure out, let me make it a little neater. You want the interest. Well, what's the interest? You have to move that decimal place over 5 times. So it's $616. Remember, charges are in dollars and cents. So it's 616.67. So on the first month, you're charged $600 in interest. Now, what was the monthly payment that we figured out, which is always going to be the same? It was $732.50. So what amount is the principal reduced by your payment? Well, most of it is interest. And this is how it's going to work. The beginning of a mortgage, most of your payment will be interest. Now, the nice thing about American incentives to purchase homes or property is that your interest payments are tax deductible. So this amount is going to be tax deductible. So it depends on your tax rate. That can help reduce your taxable income, right? Or the income taxes you pay in the end. So what is the reduction? Take C minus B. And the principal outstanding at the end of the month. So all you're going to do is take the 100,000 minus this amount. Or on your calculator, make this a negative and add 100,000. Remembering we're rounding to dollars and cents because that's how charges are made and payments as well. And then you carry forward to the second month. And now what's the interest charged on that amount? $615.95. So because the balance has gone down, your interest charge will go down. Okay, so this will be happening, but the payment stays the same. So it means that each month your principal reduction is always increased. So you can do this in Excel if you're comfortable with Excel, for practice, but you need to do it manually for the test. So, and you're not allowed to bring Excel into the test. So you need to practice. Let me know if I made any mistakes so far. I don't think so. And so now, so this goes up. This column is increasing. And this column, well, I don't know if that's the right way to do it. This increases as you go down. You're paying off more and more, and the interest charge decreases. We'll do one more, or you do it for me. Yes, good, Sandra. All right, so the last one, I'll do the third one. I mean, this is not the last one. There's going to be 300 of these, but we just wanted the first three. So remember, you can put these columns on your formula sheet. It's quite logical, but I know on a test situation, I might get anxious if you forgot something, but yeah, this is how you do it. So the last one, $615.23. Then again, the payment stays the same. And it increases the reduction this month. And the balance is now 9965035. Good. So 2, the principal outstanding will decrease. So what will happen is over time, the interest charge will fall. So at the outset, when you get a mortgage, and often young people are buying, getting a mortgage, their first mortgage, and when they're young, they're paying higher interest charges, and if they stay in that property, as they age, they're paying less interest. So you have to think about that as well. If you're counting on that interest, the interest payment reducing your taxable income, it's and ultimately the taxes you pay, it's not the case 30 years from now. Okay, if it's a 30-year mortgage. Now, we want to look at the total interest you would pay on this loan, and then we're going to talk a little bit about mortgages. Very good. So the next question, no, I need question 3. So this is pretty realistic right now. This is a reasonable rate for a mortgage. In Puerto Rico, you can get a fixed rate for 25 years. In Puerto Rico, in the States, you can also get a fixed rate. I'm not aware in Canada of a fixed rate. Most people get not variable rate, but they have to renegotiate their mortgage rate every 5 years. So we're going to talk about an example like that where you could, let's say in 5 years' time, interest rates available are lower and you have more income at your disposal. Maybe you can renegotiate for a lower rate, given your credit history has improved or it's stellar or excellent. You can negotiate a lower rate and then maybe you can work it out that you have a lower rate, but you make a higher payment and pay it off sooner, something like that. So you can change the terms after a certain period of time. So we're going to talk about that kind of example. But first, we want to talk about, I lost it. It's taken it, I need to paste it right away. First, we're going to talk about how much interest we pay for the mortgage. No, we did that already. That was number 2. I want number 3. Oh, what's going on? It's answer question 3. This is the one. I took it before. Make a whole new page. All right, there. Assuming the mortgage rate remains 7.4% for the remaining time of the mortgage, what is the total amount of interest paid during the 25-year period? So if you think about the payment remaining $732, and what were the cents? 50 cents. And you pay that for 300 months. So let's just think about it like that. Forget about time value of money for a second. What are your mortgage payments? How much, what are the total mortgage payments you've made? So people will look at this these are your mortgage payments, right? $219 and sorry, what is the total amount of interest paid? I want the interest paid. So this is the total amount of payments, but if you subtract the value of the mortgage, you can figure out, the additional is your interest payments, right? So I think that's what I did here. Let me verify. Yeah, total payments minus total principal payments for $119,750. That's your interest. So that's more than the mortgage itself. It's more than the mortgage itself. So why do people make this deal? People make this deal, right, 750, because, well, many reasons. One I mentioned to you is that interest payments are tax deductible. So you're going to save about 30% of this total value in taxes paid. If your tax rate is about 30%, 30% of this will be saving. So there's an incentive there that exists in the States, in Puerto Rico. There's the idea that your property value will appreciate because there's a tendency for that to happen. Now, historically, I mean, I'm not going to go in a huge discussion about real estate, but the idea is that when you put money into a home, the home is likely to go up in value, and so you're going to get, you might double your investment. So yeah, this was interest paid, but what if the value of this property doubles? So you've paid, of this property, $100,000 property doubles to $200,000 over time, and you can sell it and maintain, like you're keeping the purchasing power of a home over time. And the value goes up, and you're better suited to buy another home later, right? Because you can trade in that home, and you'll be receiving the appreciated value for it. So we call that owner's equity as well. Like you're putting money into this investment, and it's yours. It's not the same as buying a car that just runs down and then you dispose of it or you sell it at a reduced rate. The housing market is seen differently. So those are the kinds of reasons why people will consider taking the chance, because we really don't know what's going to happen, and they're prepared to pay more interest than the original purchasing market value of the home or the property. So let's say you buy a home in Puerto Rico, when the market is low. So let's say a $600,000 home in 2016 is purchased. So this was in 2010. The values actually went down. So this home was, I'm kind of exaggerating, but okay. So in 2016, so this is not great for these homeowners who bought at 600,000. That is only worth 300,000 in 2016. But if you buy it here, you might be able to realize, and this actually happened. I'm giving you an example of some case that I know. Now they're worth $600,000. So if you ride it out, if you're long in the position, you hold out, you can see that price go up. Now this is no gain for somebody who purchased in 2010. You're just getting, they didn't make a gain in appreciation, but if you purchased in 2016, it's another story. So timing is everything. The problem, if you have a mortgage of $600,000 and the value falls, you're really, in a bad state. Like even if you tried to refinance, you're not going to be able to get the full value of the property. So it's really bad. It's just a hard time. And I'm not giving any financial advice, just pointing out that timing is really important. Okay, so what are we? 7:30. We want a break? Take a break? 10-minute break, and we're going to finish this document, right? So let's take a 10-minute break and then finish this document and get into some of the things. I got 7 40 resume. No, it's till 9 o'clock.
Huh?
It's until 9 o'clock.
Went to the salsa.
Echo Bar. Every day is there?
Huh?
Every day they're open?
Yeah. Non-stop.
You use all the eggs already?
Four.
No, I was just in Fresh Mart.
I realized today. You want something from Freshen?
No, I just went to Fresh Mart.
I know you went to Freshen. I'm asking again because I don't know. uso las toilet paper, toilet paper.
You know, someone has to clean that kitchen. Someone has to clean that kitchen. Can you call? I've asked you 4 times, I think, already to call the maid people. I don't know why you're not calling them.
Oh, when or something.
I told you Thursday. I already told you.
Well,
You're not listening.
it's not like that. It's not like just Thursday. That's it. You want me to clean this while you give me class?
I have just leave. It's okay. Go to your thing. I'll clean.
Do you want me to clean while you give your class?
No, it's fine.
I can clean some of it, but you have to be while you give your class. Gonna be.
No, forget it. My back definitely feels better here, though.
Move to the picture.
Need an air conditioner. Yeah. Yeah, well, I don't want the one you have because it eats electricity. These guys are listening to our conversation. I don't know how it's open. Wow. All right, I'm back. I don't know. I don't like the sound so much in this room. I think I'm going to move into the other room. I'm just listening to the sound quality. Okay, so let's do the last problem. Okay, the last problem. Yeah, this is a very good one. I mean, they're all good questions. Assuming the mortgage rate remains 7.4% stated, semi-annual, after you have paid 2/3 of your monthly payments, what is the amount still remaining to be paid on the mortgage? So because of the amortization problem that we just did, you might think that you have to complete the amortization to be able to answer that question. Now, for certain, doing so would help you find the balance after 2/3 of the payments have been made, but is there a faster way to solve this? That's the question. So if there's 300 payments, two-thirds of, when you say of, you multiply 300, have been made. So that's 200 payments already made, right? So what we want to know is what's the present value at the 200th payment? One period before the 201st. How will we figure that out? Now again, don't look at the graphic. See if you can reason through it. What information do we have that helps us determine the balance outstanding? Well, we have the payment size. And that payment for the remaining 100 periods would pay off the loan, right? So why don't we use that to determine what remains, what's the balance remaining? So that is the annuity. Annuity with these payments for 100 periods. So this is a really fast way, and you might forget this method, but I don't know if you've printed the notes or how you're operating with the platform, but personally I would print all the notes up and put them in a binder, 3-ring binder, if I were you. But if not, just make highlights on this technique to find the balance remaining on 100 payments. So what would that be? You'll find out I have problems where using the mortgage, the balance remaining, you can refinance the loan with a different rate and a different payment as a result. Depending on your circumstances, maybe you can negotiate with a lower rate and pay a lower amount over the same time. Or like I mentioned before, reduce the time, make a higher payment, but at a lower rate. So what's the balance? What do you get? Well, platform got distorted. Okay, so we need to put in, let's see if he's got the right number, Luis. 5454984. So we're going to get the calculator. Let's do it together. So we have, remember, 7.4 divided by 12, and we'll put that store one. So that's 100 times the interest rate. And I said 732.50, right? So for 100 periods, that's the rate. And the payment is $732.50. Nothing in FE. So it's just an annuity, not a bond, right? We don't use all the values. And I can ask for, compute PV. There you go. So that's what I get. Just like Louise. So clearly, you need to know what problem you're facing. Is it an annuity, growing annuity? So really important, if you don't identify off immediately, to make a timeline, right? So mortgages, you know it's going to be an annuity. Coupon bonds, you know it's going to be an annuity with a time value of money for the face value. Luis, Sandra has different cents. What did I get in terms of the cents? 84 cents. Oh, that's funny. I wonder what you did there, Sandra. Don't round anything. Don't round your decimal values. Store your decimals. Okay. You might change the decimals on your interest rate. It might change your final answer. Okay. So we're done this document. Okay, looking at the other documents. Oh, I have a lot of open documents. All right, so what other documents would you like me to look at with you? And shall we solve? Should we look at continuous compounding? Which one would you like to look at together? So we've basically done all that before. So what I did was I prepared a map for you, this document. And it has it's like a summary document, like the valuation one is. So you have the formula here for converting between stated and effective rates. You have the string of equalities for converting effective to effective rates, and then I combine the two and I add in on both sides some other equivalencies. So let's talk about that. Okay, so this is I'm just going to adapt this. I'm going to develop this to what you have in your document. So these are the two rules or relationships, right? That and being aware of the subscripts that I'm using here. So I use the subscript to mean the length of compounding interval in a year. So we dealt with subscripts of 1 over 365 for 1 day in a year, right? And then monthly, right? So once in 12 months, and then quarterly, and then every half year. So those are the ones that I introduced you to. And I have them here in an equivalency, all related, because 2 halves compounded, accumulated, make a year. 4 quarters make a year. 12 months make a year. And I'm using accumulation factors each time. And so they're all equated, related by a year. Here's 365 days, make a year. But I could have more. In particular, the smallest, so you see as I'm going this way, as I'm going left, the interval, the length of the compounding interval is smaller and smaller and smaller. The smallest that we would consider is continuous compounding. The interval is so small, it's essentially 0. So what is going on there? Well, I can think about this as, you can notice the pattern here, right? You notice there's a pattern here. Actually, let's talk about that first, about the pattern. Remembering, let me erase this too. So remembering that this rule says if I'm given a stated rate, I have to divide by the number of compounding periods in a year. Well, if the compounding frequency, let me move this down a bit. If the compounding frequency or the length of the compounding interval is 101 over 365, right? Then how many, so that would be n, then how many compounding periods would there be in a year? Well, there would be 365 days would be equal to 1 over n. So these are inverses of each other. So don't get thrown off the notation. The notation's meant to help you to see a pattern, okay? So we divide R3, 1 over 365 by 365 to get the effective daily rate. So similarly, if I was given R1/2, I would have to divide it by 2 to get the effective semi-annual rate. And that would be equal to, if I had that quarterly rate, I divide it by 4, and I have to compound it 1 plus that for 4 periods to get the annual rate. So all I'm doing is combining this rule here with this equivalency here, because I want to show you how we deal with continuous compounding. Right? I hope that's neat enough for you. Okay. Now, what if we have a rate that's stated annually but compounds continuously? So these rates are stated, all of these R's are stated annually but compounded over a different interval. This is compounded every 6 months. This one is compounded every 3 months or quarters. This one is compounded every month, and this one is compounded every day. What if we compounded continuously? So what we want to do is have the n, so that's what we've done all along, right? I take R sub n and I divide by 1 over n. And then I raise it to the 1 over n. That's what I keep doing. Did that repeatedly here. And then what I'm going to do is let that n I'm going to make it as small as possible. So n is going to go to 0. So this is a limiting function of the same pattern where I'm making the interval as small as possible. It's approaching 0. In fact, you may or may not have learned this. If you took calculus, you would have learned this, or pre-calculus, you would have learned this, or maybe you learned this a while ago and you don't remember, but this is equal to the exponential function, where R0 is known as the continuous compounding rate. So I don't expect you to remember this, but that this comes next. This is the equivalency. Like basically not detail by detail in memory, but that you remember what we are doing is continuous compounding. Now notice I cannot write this as an effective rate because effectively you cannot feasibly be continuously compounding interest. Okay, so we make it it's a stated rate. R0 is a stated rate, and it's the rate, it's called the annual rate compounded continuously. And it sits right there. So how can we use this? We can take any two of these, for instance. So it says that the compounded continuous rate can be converted to the annual effective rate because you might want to be able to compare that return to other returns from other investments or financial securities, other projects, other bonds, etc. All right, so that's where that sits. Any questions, comments, confusion? You're just watching me. All right, so then on the other end, I stopped at a year, but in fact, there's rates that can compound over longer than a year period. How do we deal with that? So what if there's a rate that compounds every 2 years? There's no compounding, there's no interest paid until 2 years have passed. How do we write about that? All right, so now we have a 2, because that's a 2-year effective rate. So interest is paid every 2 years. Then to make it equivalent, you would have to partition that into a half to make it a year, equivalent to a year. So you see, this is why I use these subscripts, so then I can go either way, looking at it as a fraction of a year and then going beyond a year. And I do have an example in the test prep where I go, or in the examples that I provided, or yeah, the test prep, I think. Where if you have the 10 years, so the compounding doesn't happen for 10 years, you would write it as EPR 10, and then this would have to be partitioned into a tenth to get the equivalent annual rate. And actually, what I just wrote down is the sheet that I gave you. I expanded this to have those other rates on it. So now let's apply this. Let's see how we apply this. I should close all these. So let me make some points here. So I made this equivalency between the effective annual rate, so one period of compounding or accumulation is equivalent to the exponential function raised to the annual rate compounded continuously. So similarly, you have the first box, okay, and then you have the second box. That if I take the logarithm of both sides, then the continuously compounded rate is just the log of 1 plus the effective annual rate. Okay, so that's just algebra there. And then I say some other things. Now, you may or may not have seen this sort of computation in mathematics, in school, in high school, in biology. Often this relationship, the exponential function, is used to describe phenomena in nature. And obviously, it applies to finance as well. So all it is in the last box, the third box below, what it is the time value of money relationship. It's just the time value of money relationship. If you look at the top, I introduce or reintroduce the time value of money relationships beginning at time, any time, t, little t. And then a duration of an investment, capital T. So this takes us from the basic time value of money formula that we learned starting at time 0. You can actually start anywhere on the timeline. Then in the next row, I say, what if the interest rate is the effective annual rate? But that's just equivalent to the exponential raised to the power of the annual rate compounded continuously. And that gives us this formula that's often known as the PERT formula. So what does it do? Given a rate that compounds continuously, an annual rate compounded continuously, you can solve for the future value of that investment. So what I'm trying to do is show you that although I've taught you something that looks very confusing, it ties right back into what you originally learned. Okay, so then to solve this problem, your bank offers you a certificate which pays you $100 at the end of each of the following 3 years, carrying a stated annual continuously compounded interest rate of 8%. How can you figure out what it's worth, right? What's the present value of the security? Well, you're told that you're going to be paid $100 at the end of each of the 3 years. Payments are annual, so you need to convert your rate to an annual rate, an effective annual rate, right, for the formulas. So that's your effective annual rate. You guys can, let's see how we put that in the calculator, right, if you don't remember. So let's see, we have e to the x is up here. So I think we have to push the number first. So let's get the number. The number is 8, right? So 0.08, second function e will give us that other number. So they're close, right? 0.08 is similar to 0.083288707, but they're different. And with banks operating with trillions of dollars, those differences are serious, are large. All right, so I don't want to go there. I want to go back to, oh, I'm going to go to my calculator now, right? So let's do this on my calculator. So what I do is 0.08, second function e minus the 1. So now this is the equivalent in annual rate. So I can use this in the formula. Keep going the wrong place. And so I put it into the effective, I put it into the annuity formula for those $300 payments at the annual rate. So this is the value of that investment. That's the present value. Any questions about this? So all I've done is introduced a new rate to convert, so it's useful and practical. So we'll never have a problem where you compound or receive payments continuously. You're going to need to convert this, and this is the way you convert. Remembering this relationship up at the top. So if you have a basic time value of money relationship, this is the way you apply the rate, the continuous compounded rate. If you need, like, to solve an annuity problem like we just did, you'd need to convert the rate to the timing of the payments. Payments are annual, you need the effective annual rate. That's why we have to do this conversion in this example. Then I gave you a couple of other examples. So look at those and bring them to me next week if you're still confused, all right? We'll talk about them some more. So many things open. Okay, so there's some examples here. Try those. Then we have some review exercises. And then the prep questions. Let's look at, which one do you want to look at? So I gave you a head start on continuous compounding. Which other ones do you want to look at? You want to do something in review 1 or review 2? Have a look and see which ones you'd like me to do. So the problems increase in complexity, but still you're applying the same formula. What I want to do is check the formula sheets that I gave you. I gave you the finance formulas and I gave you the general case. So these are the formulas where the first tick mark is not necessarily at 0, right? It can be any t, any time. So it's I call it the general case. Any other problems you'd like me to look at? We have half an hour. I can do a few. So practice, practice, practice. No suggestions? Does anybody want to go early? Otherwise, we have a half an hour. Can solve a few more. Suggestions? Text me if you don't want to put it in the chat. Okay, let's do that. So we have so that one is an application of the growing annuity formula. So let's look at that one, and then I'll trust you guys to work through Unit 2, because that will take me the rest of the class to do. Okay. Okay, let's do continuous compounding. Let's do growing annuities. So these. All right, so what we have here, I introduced for the first time inflation. When there's inflation, we differentiate between the real rate and the nominal rate. Now, notice I start using the word discount rate, and you should be comfortable that that behaves like an interest rate for our formula. So you're told that the nominal rate is 8% and that the inflation rate is 2%. And then you're asked in the problem to deal with real amounts because you're told about $1,000 in real cash flow. So there's a few expressions you need to know, a few relationships. There's like 3 formulas. First, well, let's first start with talking about what real cash flows are, and then we'll get into those relationships. So you see 6 payments. So just telling you, warning you that don't get caught up with the word nominal. Everything we've done so far is dealing with nominal rates, okay? I haven't called them nominal rates. I mean, I referred to nominal when I called a rate stated, and I mentioned that word gets used a lot, nominal. Nominal means like no or little, or that's the term. That's the expression, or that's what it's trying to convey, that it's not anything in particular surprising. So all rates that you see are nominal rates unless you're told otherwise, unless you're told that the rate is a real rate. So far, I haven't mentioned that. All I'm going to do is to pick this stream of cash flows that are called real. Okay, so these are real dollars, and you're told they're $1,000. And what does it mean? It means that you're going to receive, if this is your set of cash flows to be received, you're going to receive the equivalent of what $1,000 could buy you today. So you're going to get enough money to buy the same amount of things. So let's say $1,000 will buy you a tablet, right? A computer tablet. So to have the equivalent of that in the future, and every year you get a new tablet, you need the equivalent of $1,000 purchasing power today. So that's what this is. Now, what's going to stop me from having that? Why do I have to be so specific? Well, because we're operating in a setting where there's 2% inflation. So in fact, the price of the laptop, or sorry, of the tablet is going to go up by 2% every year. Well, by stating that you're going to have the equivalent income or revenue of the purchasing power of a laptop or $1,000, that reassures you that you will, that you will be beating inflation. All right. So one of the rules are nominal cash flows must be valued with a nominal rate. Real cash flows must be valued with the real rate. So we have real cash flows, so we must use the real rates of inflation, the real rate, the real discount rate. But do we have that? Is that given to us? No, it's not given to us. So what is the relationship between nominal rates, inflation rate, and the real rate? That's the second thing I got to tell you. So some people would say the nominal rate is just the real rate adjusted for inflation. That's hard to see. Let me do that again because that's supposed to be an R. Maybe that's the impression you got from your economics class, or you learned it at some point in the popular literature. But in fact, this is not precise. This is an approximation when inflation is smaller than 2%. In reality, we're looking right now at inflation rates that are very high, much higher than 2%. So this is not going to be adequate. So in fact, this is the relationship between real and nominal rates. It's accumulation factor effect. And that we're comfortable with that because we understand compounding effects, right? So this is known as the Fisher relation. And we're going to talk about it more in the next unit. But I like to introduce it now because it's a practical application of growing annuity. So let me this is Fisher. I'll move this down. Okay, so now that you have that, you guys can figure out what is the real rate of interest, or the real discount rate, or the real rate at which buyers, not buyers and sellers, but consumers are willing to trade off consumption today for consumption next period. So calculate it. I'll do it here while you're doing it there. So what do you get? What do you get? You see, we're really eating up the time. We're really going to need the next 15 minutes. Okay, what do you get? I'm going to finish the A and B and then leave the rest for you to sort through. And we'll talk about it next class when we start back. So 1.8 divided by 1.02 equals -1. I get Sandra's answer. So I'm going to store it in 1. So it was 5.88235 ... percent. Okay, so that's stored. I'll make a note. I stored it in 1. All right, so what we found out is the real rate with the real amount. So now we have to make the annuity. We have the rate, we have the level cash flow, so we can use the annuity formula. So these are the pieces of information. So I'm going to put in boxes, black boxes, what you need to know. Well, I guess it's the whole thing. So let's make the annuity formula now. So the present value at time 0 is equal to 1,000 divided by that rate. I'm just going to write RR for real rate. 1 minus 1 over 1 plus real rate to the power 6 periods. And what you get. So now use your annuity keys, the time value of money keys for the annuity, and tell me what your answer is. So what's missing on those sheets in the solutions is I don't put the timeline in. But now I think you'll have a better idea of how to do those exercises. So yeah, give me the answer for that, and then I'll do B part. No answers? Come on. Okay, very good. So 4, 935, 55. Does anybody confirm that? So it's going to be 6, recall 1 times 100, and then 1000, 0, compute PV. Oh, that didn't work. What did I do wrong? 6 payments, recall 1 times 100, 0, 1000, compute PV. There. Good. Sandra, Louise, good. All right, so now the next part says, how do you get the same result with the growing annuity using the nominal amounts? So nominal amounts are your actual dollars in your pocket. If these are real amounts, then how much do you have to have in your pocket if there's 2% inflation? Well, you have to have more money, right? Because you're not going to be able to afford that tablet. So this timeline now, I'm going to convert it into real dollars. And the way I do that, nominal dollars, sorry. And the way I do that is realize there's going to be inflation every period. You got to keep your rate straight, right? We're talking about inflation. Inflation will increase prices. And we've assumed it's going to be at 2%. It looks really messy. So what I'm going to do is make it smaller. I'm going to say times 1.2 times 1.02 squared times 1.02 cubed. Okay. So that is essentially because inflation, so this is my symbol for inflation, pi, which I didn't mention, I just put it up here, but that's what that means. That symbol is inflation, and inflation starts right away. It doesn't wait. Okay, because it starts right away, the first term is what I need to put in my annuity formula is actually $1,020. And then now this looks more like the growing annuity formula. Etc. All right. So where this is my C1 and G is going to equal 2%. So the thing is, because of this rule, nominal cash flows with nominal rates and real cash flows with real rates, part A and B should have the same answer. The only difference is in part B, you have to use the growing annuity formula. What's the growing annuity formula? It's going to be PV0 is equal to the first cash flow, which is 1,020, divided by I minus G. What's the nominal rate? We have to use the nominal rate with the nominal amounts. It was given as 8%, so 0.08 minus the G of 0.02. And then 1 plus G over 1 plus I to the power of 6. Now you got to plug that in and you should get the same answer that you got here. To try that. Any questions for me? Can you confirm you're getting the right answer? So you're going to enter starting from here. So 1.02 divided by 1.08 equals to the power of 6 negative plus 1 and so on. So I'm going to simplify this to 6. So let's see what I can do. So I'm going to say 1.02 divided by 1.08 equals to the power of 6 equals negative plus 1. So that's my big bracket times 10, 20 divided by 0.06. It's the same answer. So all that's missing from my solutions are the drawings. If you can make the drawings better than I did, because it's kind of messy here. I would like to make it again, really. I'm going to move these up. No, it's too big. So how are you doing? That's not bad. A little cleaner. You can see it better. How are you doing? Do you get it? Okay, questions? Any questions? Can you get the right answer? So this ends up becoming the same. You should get the same answer, whether you use nominal rates or real rates. And finally, you can do the next one. Now the next one, hold on. The next question, same sort of thing, but we're going to work backwards. We're going to start with nominal cash flows. The nominal cash flows will be the same. They'll be level, $500 every year for 5 years. And we're assuming at the end of the period. And then you're going to find the real equivalent and solve the problem using the real rate and the real cash flows. If the nominal cash flows are level and there's inflation, it means that what? The real amounts will diminish, they'll decrease, okay? And that rate of decrease is what has to go into your formula for solving the annuity. So that's going to be the challenge in the second problem. So you have the answers. You should try and do it without the answers and then have a look how I did it. And that's all I'm going to say for now. So try this problem, try the others, and next week we'll have a nice review session. So I'll say goodnight for now. I have to edit out part of this video. But I think it's fine. I think you guys are on track, okay? Since you're going to have this week and the following week. So let's work steady with the documents I have. Try not to look at the solutions until you've attempted the problems. That way you'll have a better sense. And in terms of the test prep, I don't give you the worked out solutions. I just give you the answer. So in that way, you'll get feedback as to whether you know how to get the solution or whether you have the right solution or not. Okay, well, I'll say good night for now and keep in touch. Keep me posted if you have questions, comments, or concerns. Good night.